Welcome all. Today we will look into section of solids. We have already discussed the projection of solids where the solids are in simple position, and we have also discussed the projection of solids which is inclined to both HP and VP. Now in this particular session we will look into the section of solids. Actually, what is meant by section? Sectioning a solid. An object is cut by some imaginary cutting plane to understand internal details of the object. That procedure is actually known as sectioning a solid. The action of cutting is called sectioning, and the plane of cutting is called section plane. Here, two cutting actions means section planes are recommended. First one, section plane perpendicular to VP and inclined to HP. This is actually is a definition of auxiliary inclined plane, AIP. Auxiliary inclined plane means a plane which is perpendicular to VP but inclined to HP. We have already discussed that term, auxiliary inclined plane, in the previous classes, and we can represent that type of planes which is perpendicular to VP and inclined to HP as the vertical trace, and that can be represented in front view of the front view, just like this. We can represent that section plane, because the section plane which is perpendicular to VP can be represented as a straight line which is inclined to xy line. Whenever that section plane is inclined to HP, we can represent that straight line as an inclined straight line which is inclined to xy line. Here the observer is at this particular position, and in top view we can have a shortened length, or which is not in true shape, because for getting the true shape of the section plane we must look in such a way that the visual rays must be perpendicular to this particular section plane. Then only we will get the exact shape or true shape of the section plane. In top view we can't get the true shape of the section plane. And another one, section plane perpendicular to HP and inclined to VP. In that case, section plane is perpendicular to HP, so that we can represent the horizontal trace of the section plane. And these type of planes are known as auxiliary vertical plane, and we can represent that type of section plane like this. And to represent the section plane, we have utilized, or we can use a chain line like this, having ends thick line. Here chain line can be represented by the thin chain line, but both ends must be in thick lines. And remember, after launching a section plane either in front view or top view, the part towards the observer is assumed to be removed. Then only we will get the correct view of the sectioned surface. We must remove this this portion of the solid which is nearer to observer. We must remove this portion in this particular case. Then only we will get the correct view of the sectioned plane. As far as possible, the smaller part is assumed to be removed. That two conditions we have to consider during the sectioning of the solid. And this is the illustration showing important terms in sectioning. Here this is the top view, and in top view we can see the sectioned surface, and that type of top view is otherwise known as sectional top view. And this shape, this sectioned shape is actually not in true shape, but it is in apparent shape. That is otherwise known as apparent shape of the section. And we have to represent that sectioned surface by hatching, and that section lines must be inclined 45 degree to xy line, inclined 45 degree to xy line. Similarly, this is the section plane, and we must use a chain line with both and thick lines, that type of lines to represent the section plane. And for top view, exact top view, you must look in such a way that visual rays must be perpendicular to xy line. Visual rays must be perpendicular to xy line. And similarly, this is a true shape of the section. In order to get that true shape, we must look in such a way that visual rays must be perpendicular to section plane. Then only we will get the true shape of the section. Then only we will get the true shape of the section. And we must hatch that true shape in such a way that the section lines, inclined lines, must be inclined 45 degree with the corresponding xy line. That means here that corresponding section plane. This angle must be equal to 45 degree. That is the important terms in sectioning. Important terms in the sectioning. Next, these are the typical section planes and the typical shapes of section. Here, in this particular illustration, we can see that the section plane, various types of section planes are cutting the right circular cone in different ways, and we will get different different shapes of this sectioned surface. Here, in the first case, we can see that the right-angled right circular cone is cut by a section plane which is passing through the apex. That section plane is passing through this particular apex. Then the sectioned surface will have a shape like this, which is an isosceles triangle. And when the section plane is inclined to the axis, and that section plane will cut all the generators, then this particular sectioned surface having a shape of an ellipse. And when the section plane is exactly parallel to the generator, this particular generator, then they automatically that sectioned surface will have a shape of parabola. And when the section plane is parallel to axis, the section plane is parallel to this particular axis, then the sectioned surface having a shape of hyperbola. These are the most important shapes, typical shapes of sections: triangle, ellipse, parabola, then hyperbola. Then in the case of a cylinder, when we cut a cylinder like this in such a way that the section plane removes or section plane is cutting all the generators, then this sectioned surface having a shape like this, which is an ellipse. Similarly, a square pyramid, whenever the section plane is cutting a square pyramid through all slant edges, then this sectioned surface having a shape of a trapezium. That shape is just like a trapezium, not just like a trapezium, it is a trapezium. Here is the first problem. A pentagonal prism 30 mm base side and 50 mm axis is standing on HP on its base, whose one side is perpendicular to VP. It is cut by a section plane 45 degree inclined to HP through midpoint of the axis. Draw the front view and sectional top view. Sectional top view means a top view in which we have to represent the a sectioned portion. A top view in which represented the sectioned portion. That is the sectional top view. Here we can see that the base side of the pentagon is equal to 30 mm and the axis height is equal to 50 mm. First we have to construct the top view of the pentagonal prism in such a way that one of the base edge is perpendicular to VP. One of the base edges, one side is perpendicular to VP. So that this side is perpendicular to VP, we can represent the pentagon like this in such a way that one of the base edge is perpendicular to VP. Then we can draw this pentagon like this. Whenever we drawn a line like this, then the adjacent side must be inclined 108 degree with the first line. Here also 108 degree with the angle between two adjacent sides is equal to 108 degree. Similarly, we can construct or complete all the sides. All angles must be equal to 108 degree. Then in order to find out the axis point, this point is axis point, we have to draw the a construction line which is inclined 54 degree with the one side. Again we can construct another construction line which is inclined 54 degree with the 54 degree with the base edge, and the intersecting point will become the center of the pentagon. Here we can't represent the slant heights. For whenever this object is an pentagonal pyramid, then we must represent the slant heights. Here this is a pentagonal prism, so that there is no slant heights, so we can represent this pentagon like this. Here a1 is equal to this particular point in top view, and this is e5, this is d4, then c3, then b2. All are actually representing the vertical edges. Here a dash is this point and 1 dash is this point, and similarly in front view we can see point B, but E is invisible, so that this point will become B dash and E dash, and this point is O dash, and this point is here C visible and D invisible, so that C dash and D dash. Here similarly this point will become 3 dash in bracket 4 dash, and this point is equal to P dash, and this point will become 2 dash in bracket 5 dash, and this point will become O in bracket P. This is the axis point, and then we can represent the section plane. Section plane must be like this: a chain line with both ends thick, and that section plane passing through the midpoint of the axis, so that we must find out the midpoint of the axis first. Then we can draw the section plane in such a way that that section plane is inclined 45 degree with the HP, 45 degree with the horizontal line or horizontal plane or XY line. Here in the case of this particular question, we can represent that 45 degree as the angle between the section plane and XY line. Then we will get different points, which is the intersecting point of this section plane and vertical edges, and that point we can represent the by using the same notation. This point will become C dash and D dash, and this point will become B dash and E dash, and this point will become A dash. Then in order to find out the true shape, we must look in such a way that visual rays must be perpendicular to this section plane, particular section plane. Then only we will get the true shape. Otherwise, in top view we can see that A dash must coincides with this small letter A, that means this corner, and B dash and E dash is coinciding with B and E. Again, that same model, or in the same manner, C dash and D dash will coinciding with this 2 points. That means entire top view must be represented by the sectioned surface, or entire top view must be in such a way that the pentagon must be hatched. Pentagon must be represented by the hatching lines. Pentagon must be filled by hatching lines, and that hatching lines must be inclined 45 degree with the XY line. Then this top view is not the true shape of the sectioned surface. For that purpose, we must look in such a way that the visual rays must be perpendicular to the section plane. And for representing that true shape of the section, we must select a convenient XY line in such a way that that XY line must be parallel to section plane. We can select this XY line conveniently in order to avoid the intersection of this XY line and this front view. We can select this XY line outside the front view. Then we must draw the visual rays which is passing through the intersecting point A dash, B dash, E dash and C dash, D dash, and that visual rays must be perpendicular to section plane. We must draw the visual rays. Then we can mark point capital A, B, C, D, E, etc. by locating all the points on the corresponding loci. Here, this distance of capital A from the newly created x1 y1 line, that distance must be equal to the distance between the xy line and corresponding top view. We must represent this distance between this capital A and the x1 y1 must be equal to the distance between the xy line and the top view of this particular point A dash. Similarly, we can represent capital E, capital B, capital C and capital D by transferring the distance between XY line and corresponding point on the top view. Here we can say that the distance between x1, y1 and D, this small distance must be equal to this distance between XY line and small letter D. Then finally we will get the true shape, and that true shape must be hatched by the section lines in such a way that section lines must be inclined 45 degree with the corresponding XY line. That means here that XY line is x1, y1. This angle must be equal to 45 degree. And we must use capital letters to represent the true shape of the sectioned portion. That's all about today's class. Thank you all.